A tricky little time complexity question here. I think most people will get the first one correct. So we want to add together f of n and g of n. So we'd have 4n squared plus 6 plus 4n squared plus log n. And most people know that, well, as n approaches infinity, the term which dominates is the n squared. So the plus 6, it makes such a tiny difference when n is being squared that it becomes irrelevant. And the same thing with the log n. As n approaches infinity, 4n squared, or in this case 8n squared, becomes so much larger that all we're really left with is the n squared term. So we know that the first option is n squared. So straight away we're looking at a and, we're eliminating a and c. It's kind of nice the way they've done this because, I mean, I think the second question is the harder one, where we have f over g, so 4n squared plus 6 over 4n squared plus log n. I think a lot of people will be tempted to say, well, the 4n squareds cancel and we're left with something like 6 over log n, and so we'd be looking at that second answer in C. But that's actually not what happens. We have to consider the top and the bottom of these things as n approaches infinity. And again, as n approaches infinity, the 4n squared becomes so much larger that both the 6 and the log n terms become irrelevant. So we would say as n approaches infinity, what we're going to call this was j of n, wasn't it? J of n equals this. We would say j of n approaches 4n squared on 4n squared, which approaches 1. Now, a slightly more formal way of doing this, let me just scroll a teeny bit, is to divide every term by the highest dominating power. So if we divide everything by n squared, we would have 4 plus 6 over n squared over 4 plus log n over n squared. Now I think it's easier to see. As n approaches infinity, we can see that this bit approaches 0, and we can see that this bit approaches 0, because the n squared dominates the log n. So we end up with 4 over 4, and so we end up with 1. So we end up with constant time for the last one, and the answer is D.